So in this video, we're going to be continuing our theme of different principles of networking, and we're going to be talking about names and addresses. So let's start with some definitions. I'm going to start with the definition of a name. It's simply specifying what something is. It's a handle representing or identifying what an entity is. So for example, Phil and I are sitting in Phil Levis's office right now. That is the name of his office. A host name of a computer around here is market.scs.stanford.edu. This is a familiar naming convention that we're used to in the internet. And in programming, we're used to memory references, names that we attach, variable names perhaps, to represent a memory reference, in this case a pointer to a memory location. On the other hand, an address is specifying where something is. So it's identifying its location, either its geographic location in the case of an office address, so this would be the mail address of of Phil's office, or it might be indicating its location on the network, its topological address. For example, an IP address, generally speaking, is identifying the leaf where this particular address is located. So it carries with it not only the physical location, but the means to reach it. In the case of a memory address, it's identifying the actual cell of memory, the specific location of where that memory resides. So an interesting question to ask is, with a telephone number, is a telephone number a name or address? Let's go back to how telephone numbers were originally conceived. So in the US, where we have a 10-digit telephone number, starting with a 3-digit area code, it's a hierarchical address that's indicating how the telephone call is routed to that end location. The first 3 digits tell us the area, the next 3 digits tell us the exchange, and then the last 4 digits tell us which connection to that exchange. So in that sense, the telephone numbers were originally an address. They were specifying where something is. Over time, this became blurred. And today, with cellular phones, with mobile phones, the distinction has largely gone away. It's quite common for someone who lives in one area to have a mobile phone with an area code that comes from another area. It merely is giving an indication now of the name or the identity of that particular cell phone. And so nowadays that distinction really has become blurred. And in general, we're going to see that names and addresses, while they have clear definitions, can easily become blurred. And this often causes a complication. So it's not really a hard classification, but more of a conceptual model. So it's quite common for names to have a structure to them. And the structure of the name will frequently affect what you can easily reference. Many things will have a flat name. So, for example, a stock ticker, something like, in this case, Google and Microsoft, just simple flat names, airport codes. Worldwide, there's no geographic hierarchy to this. It's simply a 3-letter code identifying an airport. Services in the network, like HTTP, FTP, and HTTPS, are simply flat names. Skype IDs. We don't have in our Skype IDs any notion of the country that we reside in or any other structure to that name. It's also quite common, particularly when we're storing things into some kind of database structure, to have tuple pairs indicating characteristics of that entity that we're naming. So for example, the gender, the name, and their position, like we might see in an address book or any type of personal database. It's very common to have a hierarchical structure to names. So, for example, maps.google.com, it's indicating that within companies, we're referring to Google, and within Google, we're referring to the Maps service. So that would be the name of that service. And, for example, with hierarchical names, we might have a person in an entity within a larger entity that person resides in.
And so there are many ways in which you can structure names. But these are 3 of the most common ones: flat names, tuple pairs, and hierarchical names. And we'll see certainly in the internet that hierarchical tends to be a very common approach just for reasons of management and for reasons of scalability. But there are still cases where you have flat names or tuple pairs, as some of these examples show.
It's also common for addresses to have structure too, primarily for reasons of scale, just as with names. So for example, if we want to address things on a global scale, then it often benefits to have a structure to be able to identify them more succinctly. Flat addresses are something that we're very used to. For example, memory addresses on a computer generally referenced by the unique address, the unique flat address of a particular memory location. Port numbers, when referring to a service at a remote location, 80 refers to a web server or the HTTP service, and so on. So these are drawn from a flat address space. On the other hand, when there's a natural structure to those addresses, it's very common to represent them through a tuple. For example, a coordinate system like an XYZ location in three-dimensional space. Or as we're used to, latitude and longitude for a coordinate on the Earth's surface. Although I might point out that this one should be north and this one should be west.
Sorry, yeah, I don't sail. Sorry about that, Nick. I think this actually raises another point, is that on one hand, we're seeing a structure here of latitude and longitude and of x, y, and z. But the order of these doesn't matter. They're these independent tuples. So we could have said zyx and it would mean the same thing, which is different than when you have a hierarchy. And so there is a distinction here between sort of paired elements or tuples and then a hierarchy where the order of the elements matters.
An example of a hierarchical address might be when we're referring to memory segments on a disk. We might be referring to a segment, which is a broad classification, and then a particular address within that segment. So here's a hierarchy giving us a nice succinct representation that tells us even more information about where something is located. Another one is, of course, the hierarchical address of a mail address, which is giving us successive information about the specifics ending up with the precise location that we're referring to.
So let me try and ground these concepts of names versus addresses into an example. So let's say I want to download a file from the internet. And let's say you want to, for some reason, I don't know why, download my homepage or my publications page. I'm an academic, it's very important. So an address says that the page is at http://csl.stanford.edu, that's the web server that hosts my web page, ~pal, that's me, pubs.html. What this is doing is it's referring to what host the file is on, csl.stanford.edu. So in that way, it's a name. It's not quite an address. But still, there are some tensions there we'll talk about in a minute. But then this later part of the URL is really specifying where that file is, where on the host file system. It turns out it's in my public HTML directory and then pubs.html. And so if I were to move the file, or I change its name, say, to publications.html, this address would no longer work. Similarly, if my web page were no longer on csl.stanford.edu, but instead I hosted it on sing.stanford.edu, which is my research group's host, this address would no longer work. Now let's take, in contrast, the most extreme version of a name, which would be that I take pubs.html, and I compute a hash. Basically, it's this long number that is a summary of all of the data, and such that I can say, look, if the hash matches, it's high probability the file matches as well. And then what I would do is I would somehow sort of ask someone, hey, I have this hash. Where does this thing reside? And it might give me a host name, or it might give me an IP address. And then I would ask, using some protocol other than HTTP, because HTTP talks in terms of addresses, I would then ask for that particular file. And so what's interesting is because I'm computing this hash and I'm naming the file in terms of a hash, that's naming what it is. It's actually naming the data. If I change the file, the hash changes. And so if I were to suddenly update my pubs.html, I would have a different hash and a different file. Unlike here, we're using an address. It's a different data. It's a different meaning in the same place. But correspondingly, I mean, this hash says nothing about where it is. It's just a hash describing the file. So here's this example of sort of an address versus a name, stating where it is versus what it is. Now, in the internet, we use both addresses and names. Addresses because they allow you to have a sense of, say, the network topology and route things better. Names because often they're much more useful and more flexible. I'd like to say what a host is, not where it is. So, for example, as you've seen a couple of times so far, in the internet, the two major kinds of addresses we often talk about are typically there's the 32-bit, called an IP address or IP version 4 address. So we see something like 171.66.5.9. That's a 32-bit IP address represented as 4 8-bit numbers. And they're also sort of the future version of IP version 6. Their addresses are 128 bits long, much longer. We'll talk about them later in the course. But now in terms of names, the most common names we talk about on the internet are domain names. So for example, here is the domain name for Stanford's web server. Or also even just the domain name of stanford.edu. That's a name that we can use and talk about. And there are ways to translate from these names to these addresses. Of course, that's just at the internet protocol at the sort of the host level. There are many more names and addresses using the internet at higher layers. So as one of the examples Nick talked about, you have service names like HTTP, but then there's also a port, which is actually the transport identifiers or the address of where you would talk talk using HTTP, which happens to be 80. And so there are mappings between these service names and port numbers. Here's a slightly different example, which is kind of interesting because the structure of the name and address is the same. They look the same, but they're used very differently. So we have SIP identifiers. SIP is a session initiation protocol. It's for IP telephony, voice over IP. And so a SIP identifier is a name. That just because I use the SIP identifier pal at a.com doesn't mean that I'm at a.com. This is just sort of a lookup to then ask a.com, where is Phil? It might be that I'm in, I'm in Paris, and so when you make a call, it should connect you to Paris, not to a.com. In contrast, an email address is really an address. It's saying you need to deliver this message to pal at a.com's mail server. And so you have something which looks the same, right? And they used this in SIP basically just for familiarity, right? It's a nice thing people know about. But on one hand, it's a name that doesn't say at all where that IP telephony connection is going to go. In the case of email, it's in fact saying where the email is going to go. And so it turns out that managing names and addresses, there's this Internet Corporation for Assigned Names and Numbers, ICANN, that manages all this kind of stuff, decides on who gets domains, and this, there's also this IANA, which is currently managed by ICANN, has been in the past, which is who decides what the mapping are between ports and service names. And so there are organizations that try to give some method to the madness and provide some structure in the internet between names and addresses. So just to try to sort of, because this distinction can be a bit fuzzy, we're just going to walk through two examples to try to make it, two more examples to make it clearer. So let's look at, I want to look at my web page because I'm very vain. And so one, I could say, look, I'm going to look at my web page in terms of csl.stanford.edu/pal. So that's the host name. And that's where my web page is. And so I give you this, this way to reach my web page. If I wanted to, I could also give you HTTP 171.64.73.43, so an IP address rather than a host name ~pal. Both of these will work. But the difference is that if for some reason the person who manages this particular host, CSL, within the CS department, wanted to move the CSL web server or its CSL services onto another machine with a different IP address, so not 171.64.73.43, but they still want to keep this old machine up. They wanted to basically change all these services to some new, faster machine. If I handed you this IP address-based address, you wouldn't be able to find the new page. It's pointing you towards a specific machine, not to a name, a host name. In contrast, if I gave you this, then the person can migrate all the services over to the new machine, which has some different IP address, then update the name system so that suddenly this name will point to the new IP address, and then you would see my web page properly and nothing would be disrupted. So this is an example of how specific, are we talking about the address of a host or the name of a host, which allows you to then change what the address is.
Phil just described an example where the service is moving. The similar problem arises if the user is moving. So imagine now that I have a, this is me. This is a poor drawing of me, and I'm currently engaged in a telephone connection, voice over IP, so voice going over the internet, and I'm currently using my local Wi-Fi to connect me over to, across the network, to somebody at the other end. Here's Phil over here. And I'm walking around and suddenly there's a stronger signal that comes through, instead of through my Wi-Fi, that comes through my cellular connection. And so my phone decides to break this connection and go on this way, still maintaining that call. This can work today. There's a little bit of trickery and magic that has to go on in the background to overcome this complication of the addressing. Because in the internet, we commonly use addresses, we always use addresses in fact, for packets to reach their destination. The problem here is that the destination, me, has moved to a different network, and so my address has changed. So I'm still the same phone, I'm still in the same location, but my topological location has moved. I've now appeared by going through this path. And so in order for that data from Phil to reach me, it now has to take a different path. So Phil, when he initiated the call, was initiating the call to Nick. He was just using the name to reach me. Underneath that was the mechanism to handle the addresses. And the little complication that we have to deal with these days is that address has become a little bit muddled as users start to move, just as in the example that Phil was showing of the service needing to move as that gets upgraded to a new machine.
So of the principles we're going to talk about, this one is perhaps the most subtle and the most difficult. And because it is something that's, how you structure a name or an address and whether you use a name or an address can have really deep implications to then what's easy and what's hard, what your system can do and what it can't do. And there are no hard and fast rules for how this is. And so throughout the course, we're going to give you examples of situations where names are used, where addresses are used, how they're assigned, how they're structured. And so when you're designing a new network system, this is something you really want to pay attention to in terms of how the data or how the entities or how the host, whatever it is named or addressed, and then whether it's named or addressed, and then how it's named and addressed.